Hello, everyone, and thank you for coming to our 1 p.m. block for Day to Day. It is my absolute pleasure to introduce today's speaker, Theodore Stumpf. Theodore is currently serving as our senior data scientist with the State of Indiana Management Performance Hub, where he supports various data and AI-related efforts. Today, he'll be introducing DocuSage and demonstrating how developing in-house AI tools is a fantastic opportunity to create AI products in an efficient and cost-effective way. I have no doubt you'll find his perspectives on AI insightful and informative. Please join me in welcoming Theodore Stumpf.
Hello, thank you all for coming. I'm Theodore Stumpf. I'm a senior data scientist at the Management Performance Hub, and today I'm going to be talking about how your documents are holding out on you. Now, before we fully get into it, I have some common definitions that I would like to go over. If you've used Copilot or any other AI software personally, you're all familiar with what these at least are. So LLM, that stands for large language model. It's an AI that generates text, but specifically it refers to like the brain of the tool. In this presentation, I'm going to be using large language model and AI more or less interchangeably. The specifics don't matter too much here. You have context window. Every large language model has a limit to the amount of text that it can take in at once. A few years ago, that was measured in the thousands of words. Now it's measured in the hundreds of thousands or even millions of words, which you don't hit the same limits that you used to, but when working with long documents, you still can. Inference, that's just the process of the large language model actually generating text, and that's where the bulk of your costs are going to come from with AI tools. I'm going to refer to documents a lot, and that isn't just Word documents. That can be any sort of file that holds text data. So Word documents, text files, PDFs, web pages, PowerPoint slides, emails, computer code. If it holds text, I'm considering it a document for the purposes of this presentation. And then lastly, I'm going to be talking about tools, which are software components designed specifically for large language models. So, brief overview of what I'm going to cover today. I'm going to talk about why we want to give large language models long documents. I'm going to talk about DocuSage, which is an in-house tool I made for MPH for the purpose of processing documents. I'm going to talk a bit about how large language models process long documents. I'm going to talk about some of the limitations that large language models have, and I'm going to talk about how you can surpass those limitations. So I'll start at the beginning. Why do we want to give large language models long documents? It's because large language models excel at processing text. A large language model can read a book in seconds, and many of us here at the state have to deal with long documents on a daily basis. But if you're using just long documents, you're going to run into some issues. The first of which is traceability. If you give a large language model a 200-page document and you ask it a question, it's probably going to give you an answer. But how easy is it to check that the answer it gave you is correct? Not very. There's also the issue of noise. If you're giving a large language model a whole document, you're giving it a lot of information that it doesn't need to answer your question, but it might include in its answer thinking that it's relevant. And then there's the matter of cost. Large language models charge by the word. And so if you give it a 200-page document, but what you actually need it to read is only 3 pages of it, you're paying for 197 pages that the model doesn't care about and it doesn't help you. And so what is the solution? The solution is building smart tools that a large language model can use to help process these documents. You can make a smart tool that is traceable, accurate, and efficient. A good example of this is, think of ChatGPT and where it was at 2 years ago and where it's at now. There have been some improvements to the large language model that powers it, but as a user, what has improved the most is the tools that ChatGPT has access to. Another example is, here at the state, is Microsoft Copilot. The difference between Copilot Chat and Copilot 365 isn't necessarily the model, it's what tools the model has access to. Copilot 365 has tools that it can use to integrate directly with the Microsoft Office suite. Then I also just want to talk a little first about how cost impacts you, because I would imagine the majority here use a subscription service rather than paying every single time you use the model. But let's go through some examples. So say you have a 200-page document. That's going to be around 55,000 words. And if we use a cost of $3.60 per 1 million words, which is about average for a mid-scale model, it's going to come out to about 20 cents every single time you ask a question or a follow-up question about that document. But let's say you have some smart tooling that is able to find those 3 pages that matter most to your question. That's only 825 words. And so at that price point, every time you ask the model a question, that is 1/3 of a cent. And so last example, let's say you have a very long document that is 1,500 pages long. That is over 400,000 words. And so if you were to put that directly into a large language model, that would be $1.50. Now, I use the free version of Copilot. And just the other day, I put a document that is over 1,500 pages long into the chat. And I asked it a question. And it gave me a reply, gave me an accurate reply. But Microsoft isn't processing the entire document directly with the large language model. They are using smart tooling to help find the relevant pages that I'm asking about and source its answer from there. So even if you're using a subscription service, the company providing it is using tooling behind the scenes to reduce cost. So now I'm going to talk about DocuSage, which is an in-house tool I made for MPH. Just first, a quick disclaimer, DocuSage is an internal application created specifically for MPH-defined use cases. It's intended for exploration and testing rather than a full rollout, and it's not available to other agencies at this time. However, our leadership team is actively collaborating with the state of Indiana leadership across all agencies to explore opportunities for enterprise AI solutions in the upcoming budget cycle. So now, what is DocuSage? DocuSage allows users to build collections of documents called catalogs and then chat with an AI agents to ask questions about the content contained within those catalogs. It's a tool I made that runs locally on a server we have and is accessible to people within our agency. And it focuses on combining local processing power with a large language model that we use through our Amazon Web Services sandbox. So this is what the homepage looks like. Now I'm going to talk a little bit about catalogs. Catalogs are a collection of documents with a shared purpose. And so for DocuSage, those can be text files, and it can even be scanned PDFs because it performs text extraction on the PDFs to get the text contained within. And so when you build your catalog, you make it out of documents that you would want grouped together when you search. So say your agency has a bunch of policy documents that you want searched together, or maybe you have a team project with multiple pieces of documentation. You can put them all together. There's also some pre-processing done, which I'll get to later, but I refer to that as compiling a catalog. It's a somewhat time-consuming, roughly 5 minutes per document, but it's a one-time thing. It only needs to be done when you first make it or when you update a document. So once you have your catalogs compiled, you can go to DocuSage chat to help answer most questions that you have about your documents. So you can see on the side, there's a list of catalogs, and you can select one or more catalogs. So say what you're using this for is analyzing project proposals. You could have one catalog that is the rubric and everything you want the project proposal to be graded by, and another catalog could be an actual project proposal submission. You can select both and then ask the AI agent, hey, how well does this proposal align with the rubric you've been given? For this example, I'm going to be going through the book, Software Engineering for Data Scientists by Catherine Nelson. It's a 260-page long book, and it's been very helpful for testing this. So I'm going to ask it a question. I'm going to say, hey, how do I make my own API? And the agent is going to start thinking. And so here's an example of the thinking steps. I wasn't able to get a good screenshot of it, but if you hover over these boxes, you are able to see exactly what it is that the AI is outputting for each step of the thinking process. And once it has its answer, it goes, great, I found helpful information about creating your own API. Here's a guide based on the documentation, and it'll write out a summary of what it found. And down here, if you scroll to the bottom of the message, it has sources, not just to the specific file that it found the information, but the specific pages that it found that information on. And if we look back at the chat, you can see that in the chat, there are citation numbers, and these citation numbers are links. And you can click on these links, and it will take you to the source document, and it will scroll automatically to the page where the information was found. DocuSage doesn't just tell you what your documents say, it tells you where they say it. And so this makes it very easy to double check that what the tool is saying is accurate. DocuSage also has a feature called user groups, which allow for easy sharing of catalogs. When you first create a catalog, it's designated as a user catalog. Only you can see and access and search it. But you can be assigned to be a part of different user groups. And one of the options you have is you can choose to share a catalog with any group that you're a user of. So say it's a project documentation, you can choose to share that catalog with your project team. And now anyone on that team can search your catalog. They can chat with it with the AI agent. And then lastly, administrators have the ability to mark a catalog as a global catalog, meaning that anyone on that specific server within an agency for DocuSage can access and search that catalog. So HR policy documentation could be still owned and edited by the HR team, but it can be searchable by anyone in the agency. Now, I do need to note that the state's AI policy does still apply. So no sensitive information should be used with a tool like this, because at the end of the day, it still does go to an AI service provider. So what are the use cases for DocuSage? One is our security team. They have to search these large security frameworks and find specific citations for the security standards that they are enforcing. And DocuSage helps them quickly locate, okay, it's specifically this page, it's this standard number. The legal team uses it for locating prior examples and precedents that we have across data sharing agreements. And the project management team uses it to find information in project charters. Now I'm going to be taking a deeper look into the systems behind DocuSage. This is specifically how DocuSage works, but a lot of this applies to many AI tools. But first, I'm going to give a bit of an example. I'm going to talk about how do you predict the weather? Well, the first step is you have to take measurements. Things like wind speed, cloud coverage, temperature, what time of the year it is. And then you need a system that can turn all of that into just raw numerical data. So, hey, here's all the numerical data for the past, say, 30 days. And then you can feed that into a predictive model that is designed to predict, given what the past 30 days of weather are, what's the weather likely to be tomorrow? And it'll output this same format of numerical data of what it thinks the weather is going to be tomorrow. Well, what if you want to find out what the weather is going to be 2 days in the future? You can just take the output, put it back as part of the input, and pretend like that's what the weather actually is going to be. And then you can feed it through the predictive model again to get what the weather is going to be like 2 days in the future. And you can repeat that, taking the outputs and putting them back onto the inputs until you get, say, 14 days out. So now you have weather predictions for what the next 2 weeks are going to be like. But you're still left with a big pile of just numbers. And so the final step is to take all of those numbers and convert it back into output that regular people can understand. Like this lovely forecast we had in March, where it was 83 one day and 27 degrees the next day. So how does this all relate? Computers aren't good with words, but computers are very good with numbers. So large language models use a process called tokenization to take the text you've written, your words and the grammar, and turn it into a big long string of numbers. And then we can take that big long list of numbers and feed it into a predictive model and say, hey, which number is likely to come next? And so the predictive model will pick, okay, what number comes next in the series? And one thing to note is slight difference between the weather and this is large language models typically choose from a pool of like the 5 or 10 most likely numbers to come next rather than whatever is most likely. But using this model, we can get the next number. Well, we can then take that number, put it back onto the input, and run it through the model again. So now we have the next 2 and 3, and we can keep going until we have either hit a stop limit or a specific number that we've told the model means stop generating new numbers. Well, now we have a big long string of numbers that our predictive model has generated. We can take that and we can reverse the tokenization process to get output text. And so this is how large language models on a high level generate text. And there's a few things to note. One, because they do pick from a pool of most likely next tokens, that does give them an element of creativity. So if you've ever hit the rerun prompt button in an AI without changing anything, you probably got a slightly different output. But that can also introduce some randomness into the system, which is something to look out for. Another thing is it is completely stateless. There's no memory other than what is in the input tokens. So when you're chatting with an AI model, it's having to feed all of your previous conversation in as part of the large language model's input. The other kind of secret sauce I want to talk about, and this is where the big cost reduction component comes in, is Retrieval Augmented Generation, or RAG. And there's many different types of RAG, page index, keyword, graph RAG, but I'm going to talk about vector RAG, also known as semantic search or vector search. It's one of the more common types. I'm pretty sure it's what Copilot uses when you're chatting with documents, and it's what DocuSage uses. So I'll give you an example. Let's say we have a bunch of fruit, and we want to know which fruit is most like a strawberry. Well, if we were to just try and ask a computer this somehow, it would have no clue. It doesn't know what fruit is or anything like that. But let's say we build a model where we give it a fruit, and it ranks the fruit based on size and sweetness. Well, now we can put all of the source reference fruit we have through this model and rank it based on size and sweetness. And then we can do the same thing with our strawberry. And now it's a lot easier to ask, hey, which fruits are most like a strawberry? Because it's on a map. We can just calculate the distance between the strawberry and the other fruit and find out what's most similar. So how does this relate to DocuSage? Well, it does more or less the same thing with your documents. It takes your documents and it breaks them into tiny pieces. And then it feeds them into an embedding model that just ranks them on a bunch of different categories to try and get the semantic meaning. It doesn't care about the exact words. It cares about what this chunk of text means. And it places them onto a map. Although instead of being 2 dimensions, it's 384 dimensions, a bit harder to represent. But what this allows us to do is it allows us to find pieces of text that are similar to each other. And it allows us to write our own messages and find, hey, in the source documents, what chunks are most similar to what I just wrote. And so it allows us to do a search without having to know the exact words, because we only have to guess at the meaning of what is being said in the source document. And so what ties the two together? Because the large language model is one process, the vector search is another process. What ties them together is the agentic framework. Large language models, they're great at generating human-sounding text and things like emails, but you can also use them to make decisions and use tools. So DocuSage, it uses a custom-built AI agent to just look at the request you've sent. So if you've just said, hi. It'll look at your message saying hi, and it'll go, do I have enough information to answer this question? Well, the user's just saying hi, so I'll say something back like, hi, how can I help you today? Would you like to search your documents? But if you ask it a question, like I have here, it'll go, okay, do I have enough information to answer the question? And it'll look at the fact that it hasn't fetched any information yet and go, no, I need to do a search. And so it'll look at the list of documents that it has access to and it'll go, okay, what do I think the answer in these documents is going to look like? And it'll write out a few guesses as to what it thinks the answer is going to be. It then sends those to the vector search tool, which will use that encoding map to find what parts of your documents are most similar to what it thinks the answer is going to be. It'll send those back to the AI agent, and the AI agent will look over it again and go, okay, did the search work? Do I now have enough information to answer the question? At which point, usually on the first attempt, it does. And if not, it'll search again 2 or 3 times before deciding either it does have enough information or maybe the information it's looking for isn't in these documents, and it'll tell you that. So I just also want to point out here, I am searching the entirety of the Indiana State Legal Code. So this is around 21 million tokens of input. The best kind of publicly available models have 1 million tokens of input. So this is 21 times the size of even some of the best models out there. And if you were to put it all through a large language model, it would cost you around $65 per question. This is running entirely locally on my laptop, and the AI side of it is costing about 3.5 cents. So I'm going to give an overview. I know that was a lot. So here's just a flow chart about how the chat system works. So you start with all of your documents, you put them into a catalog. The catalog is compiled, which is the chunking and encoding of those documents. And then you go to the chat system and you send it a message. So the DocuSage then calls to our AI service provider and says, hey, here's the user's question. And so the AI agent goes, okay, do I have enough information to answer this question? It doesn't. It hasn't loaded any information yet. So it'll dispatch a vector tool search, which will then grab the relevant information from your documents and send those back to the AI agent. So the AI agent will look again and it'll go, do I have the information to answer this? Yes, I do. And so it'll write out its response. But now I'm going to talk about the limitations of DocuSage chat. And really, these are limitations of all large language models. The biggest benefit of large language models is that they can generate new text that no human has ever seen or ever written. But that can lead to them making a lot of mistakes, and we refer to those mistakes as hallucinations. And one hallucination that I run into all the time is regarding MPH. I work for the Management Performance Hub. If you ask pretty much any large language model, hey, what agency is MPH? It'll go, oh, that is the Ministry of Public Health. Even if I specify Indiana State Government, the majority of the time it'll think I'm talking about the Ministry of Public Health, despite Indiana not even having a Ministry of Public Health. And the reason for that is in the training data, MPH stands for Ministry of Public Health a lot more than it stands for the Management Performance Hub. Large language models are very good with general common things, but they really struggle when you try to get specifics, especially if you haven't provided those details. That's one of the benefits of using Retrieval Augmented Generation, is it allows the AI to get those specific details from your documents. But even with Retrieval Augmented Generation, AI can still make mistakes. And it can also make mistakes with its logic. I recently was working on a personal project and I was having some issue getting software to run on my computer at home. And so I turned to AI and I was like, hey, here's the software I'm trying to get working. Here's the error I'm running into. Here's what operating system I'm using. Can you help? And it was like, sure, I can help. And it searched the web and it came back. It found other people having my issue. It found what worked for them. And it printed me out a great guide for the completely wrong operating system, despite me explicitly stating that in the prompt. So always review the output of large language models. Oh, another place where this can pop up is large language models are now being trained on the output of other large language models. One issue that brings up is they can start hallucinating about what they can and cannot do because they've learned in their training data, here's how other large language models respond, even though it doesn't have that same capability. So unless a large language model has a very good system prompt explaining exactly what it can and cannot do, asking a large language model, hey, what can you do, doesn't always get you accurate results. Here's an example of a hallucination. I just asked an AI very nicely, hey, can you please show me the seahorse emoji? It goes, here you go, the seahorse emoji is, just kidding, that's a peacock. Here's the real one you want. Also not it, that's a shrimp. Okay, for real this time. Nope, coral. And this will go on and on for a while because the AI believes that the seahorse emoji does exist and that it's somehow just making a mistake when it prints out the wrong emoji. And that gets into my next point, reasoning. When you ask a large language model to say, justify like, hey, why did you answer like that? You're probably going to get a reasonable sounding answer out. But the issue is that it doesn't know what its reasoning was. All it has is input. You could have written out by hand what, oh, here's my question and here's the large language model. And it would have no way of knowing it, that like, oh, that's what I said, or whether, it was human written. And so, because if you think back to my example of how they work, all they have to go off of is the input tokens they have. So there is no connection between the explanation it gives and the decisions it was making when it was predicting the answer to your original question. They can't look back. They don't have the ability to be introspective. I mean, an example here, we have the whole seahorse thing still going. And it's going on because the AI model is trying to predict the next token. And so it tries to predict what the most likely token for saying, here's the seahorse emoji. What's the next most likely token? Well, the seahorse emoji doesn't exist. And so it generates some other emoji. But now it's in a position where it has to try to, predict what token comes after. Well, it made a mistake, so it'll, play it off as a joke. But at no point does it really stop and go, hang on, I've tried a couple times and I'm just not able to do it. Maybe there's something else going on here because it's just trying to predict what the next token is. So an AI can never really show its work. Large language models also can't do math, at least not without tools. And that comes down to a variety of factors, but a big one is they see numbers very differently than we see numbers. I have here the same number written just two different ways, along with the list of tokens. So this is actually how these numbers look to a large language model. And as you can see, they are quite different. Not only is the number of tokens different, the grouping of the numbers is different. Numbers also lack the same explicit meaning that words do, especially once you get past single-digit numbers, saying, oh, this room can hold 374 people versus this room can hold 373 people. Changing the number a little doesn't really change the meaning of a sentence at all. And so when a large language model is generating and it generates a list of what are the most likely next tokens, a wrong answer to a math problem isn't grammatically wrong. And large language models care a lot more about grammatical correctness than they do mathematical correctness. And the other part is they choose randomly from a list of most likely tokens. And that's just not how math works. You don't really choose randomly when calculating the answer to a problem. And It's not always consistent, but in my testing, some large language models fail to consistently add two 7-digit numbers together. Often the errors were minor, but off by a digit in one place or another. So can't really do math. They also can't count. Got a bit of a pop quiz. How many R's are there in the word strawberry? Is it A, 2, B, 3, C, none, or D, 12? Now for us, this is a fairly easy question to answer. We can just count the letters and go, oh, it's clearly B, 3. Well, here's how it looks to a large language model. As you can see, there's no R's. The word strawberry itself is made up of 3 separate tokens. And so it doesn't really have a concept of what is the letter R. And, here's how the answers look. Again, it's just completely different from how we see it. So large language models, they can struggle to count text elements, as well as the number of occurrences of items within one or more documents. So if you say, hey, can you show me every time this phrase appears in a document, or can you list every document that has this specific bit of text, it's going to struggle. Will it get you some results? Absolutely. But if you have 10 documents and you say, hey, can you show me every time this phrase comes up, and it gives you 7 results, you can't really be sure that it has given you every occurrence. Those 7 occurrences will probably be accurate, but you can't be assured that that's all of them. This is also an area where retrieval augmented generation actually works against you, because the entire purpose is to reduce the amount of text that gets sent to an AI. So in DocuSage, I have the number of results capped at 3 to 5, depending on the size of the search. So if there's 7 matches across the document, the AI is only ever going to see whichever 5 most closely match the search phrase that's been used. But this was a question that actually came up a lot when talking with people at NPH about how would you use DocuSage. Is they're like, oh, we would love to know for every document in a set of documents we have, who's the author, or when was this document made, questions like that. And so they wanted to go from unstructured data to structured data. And that's not something that DocuSage Chat can do. They wanted bulk data from documents. And this does tie in to the project that we did with the great folks over at IDOA, and a way to take the process of what DocuSage does for a single document and then apply it to every document in a catalog, a tool that can take a set of unstructured documents and give you a spreadsheet that is filled with the information that you want. So I'm going to use some contracts from the Indiana Transparency Portal kind of as an example, but really any set of documents that you could be turned into a spreadsheet in one way or another is a valid use case for this. So this is the tool I made, DocuSage Extract. It uses many of the same components that that DocuSage Chat does. Primarily, it uses catalogs, the vector search, but then it also takes in an extraction query. And so you build the extraction query here. And this is where you define what data specifically do you want out of the catalog. And so there's kind of 2 main components. There's the document context. And this is just a short bit of text that tells the AI what the document is. And it just helps set the tone of the answers that you're getting out of it. And then you have all of the output fields that you want. And each output field has 5 elements to it. The first is the field name. This is just what is the name of the column in the final spreadsheet. Then you have the description or the example. And this is where you tell the AI, what do you want this field to be filled with? And then you have the default value. The default value is just the text unknown. But if you want to keep types consistent in a column, you can change it to a 0 or a date or null, NA, just whatever value you want. And then lastly, not lastly, 4 out of 5, there's a semantic search field where you can define strings that you want it to use the vector search to grab chunks from your document that probably contain the answer to this field. The last one is a little toggle on the side where you can select whether it's a single value or a list of values. Now, you do need to be careful with the list of values because you don't want to run into another every problem of asking it, hey, show me every time this appears in the document. But if you know it's something like a list of names of people who signed the document, that's all going to be in one place, using a list is okay. And then down at the bottom, you can see the prompt that it makes. And if any of you attended my friend and coworker Dr. Horton's presentation this morning, this might look a little bit familiar because it generates for you a structured prompt. And so you can use this for testing if you want, or you can go to the extract tool. And the extract process itself is as easy as selecting a catalog that has all your documents, selecting a extraction query that you want to run against it, and pressing start. There are a few other options. For example, if you know that the first 2 to 3 pages contain a lot of useful information, you can just set those pages to be automatically included by default. You can also set the number of search results per field. So it's a trade-off between the amount of information included and the cost. But if you only have, say, a few hundred documents that have wildly different layouts, it might be worth bumping that up to 5 or maybe even 7. But if you're dealing with very structured documents that have, repetitive language and the documents themselves are very similar, you can keep it at 2 or 3 and save on the processing cost. And when you're done, you get a spreadsheet that looks like this. And each column is a field that you specified in the extraction query, and each row is one of the documents in your catalog. It does take a while to process, but it leverages batch inference. So we'll get into that. A few key differences between DocuSage Extract and DocuSage Chat. The first is segmentation. DocuSage Chat, when you first invoke the chat agent, it's going to search every document you have in your catalog. Whereas this, it keeps all of the documents separate. The second is batch inference. When you're using DocuSage Chat and you send a message, it reaches out to the AI service provider and it says, hey, I have a request for you. Please get me the answer as quickly as possible. The user is waiting. And so it gets the reply and it displays it to you quickly. With DocuSage Extract, we're dealing with hundreds, if not thousands of requests. So it's already going to take a while. Well, we can package those into a bulk data request. We can say, hey, Amazon Web Services, I have a bulk request for you. You get to it when you have the time. And as a trade-off for having to wait, you get a 50% discount, which if you're doing a lot of data processing, a 50% discount is very much worth it to take it from a 2-hour task to perhaps an overnight task. The lastly part is there's no agentic search. DocuSage Extract is designed to send more information at once, but with the hope that it is enough information for everything to be processed successfully the first time. If information couldn't be found in that first pass, there's a good chance that it doesn't actually exist within the document. Or if enough are failing, that's a sign that you need to go back to that search query and refine it, which DocuSage does have tools to help you refine and improve those vector search queries. So I'm going to walk you through DocuSage Extract and how it works the same way I did with DocuSage Chat. So first, you have your input documents. Those are chunked and encoded, just like before, but importantly, they are kept separate from each other. And then you write your extraction query, and then when you hit run, it starts building out this bulk data request. So first, it does the vector search, and for each document, it returns every matching field that it finds. Then Any pages that you've designated to be included by default are added into this bulk data request. It's sent off for batch inference. And then you have to wait and wait. Sometimes it's half an hour. Sometimes it's 6 hours. You never know. But when it's done, you get your final result, which is that spreadsheet showing all of the data extracted from your documents. So, in conclusion, when thinking about what problems you want AI to solve, it's worth it to take the time to think. What components need AI and which ones can be optimized without using large language models, even if you're using agents to augment the process. And this applies whether you're building your own solution or looking to buy a pre-made solution. It's worth knowing what components use AI and where optimization in cost and efficiency, and sometimes even time, can be found. As an example, DocuSage is designed to be precise about where the answers it gives you come from, and it's designed to be smart about what it costs to find them. But the key takeaway is this. Large language models are powerful, but they have real limitations. And the answer isn't to avoid them, it's to build smart structure around them. Thank you.
Thank you, Theo. We have time for some questions. Raise your hand.
Hi there.
Hello.
I just want to say that really explains a lot about why sometimes queries don't work. So thank you. Really good. My question is, could DocuSage potentially work with handwritten documents, like high resolution
Yes.
scans in cursive and things like that?
Yes. So part of the compilation process is it tries to extract text from the document it's been given. If that fails, it falls back to using optical character recognition, which it's a bit more of a lengthy process, but it converts that PDF in that or scanned image into a text file that contains the text in it. So yes, it does work with handwritten documents.
So it seems like you've been testing this primarily on like the IC and other publicly facing materials. I was curious to know if there's been any consideration for possible current or future usage around materials that we could consider more sensitive to various agencies for various reasons.
That's certainly a possibility. The big limitation is just the state's AI policy.
Totally
And so for anything involving sensitive materials, that would require special review, permissions, and likely additional oversight.
Mhm.
But from a technical standpoint, it is possible.
Okay, thank you for that. I appreciate it.
But for specific questions as well, you can reach out to info@mph.in.gov for policy questions.
So you talked a lot about cost per
Mhm.
query or whatever. That's not something that we culturally around AI have spent a lot of time thinking about. So for the state of Indiana, what is the cost structure? Like if I'm just using Copilot chat, like are we limited based on the subscription, or how does that work?
I'm not too familiar with the specific limits Copilot has. Personally, I know with some of the AI tools I have, they have a usage limit where if I use it too much and in one sitting, I get blocked out temporarily. The big reason I bring up cost is even though the majority of us do use subscriptions, the company behind it is still having to manage the cost of it, and they're looking for ways to improve the efficiency on the back end. So in my testing with Copilot, it does something very similar to DocuSage, at least when it comes to the processing of the document, breaking it down into chunks and then performing a vector search, which is much cheaper than processing the entire document.
If I could add, IoTs who manages our Microsoft subscription and everything involving Copilot. So we can get you contact to ask more specific questions there.
So this is probably too loud, sorry. This is probably a little bit more toward form or document format than necessarily the tool itself. In terms of if we are, or the document that we're using, is it likely to yield different results or better results depending on the format that we submit it in? So like submitting a CSV rather than Excel, or a TXT file rather than Word, or anything like that?
For the most part, no. I would say DocuSage on the back end more or less converts everything into a text file. And so the closer what you have is to a text file, the less chance there is of something getting messed up in the conversion. So if you have a PDF that's broken up into 2 different columns in the same page, that runs the risk of when it gets converted, not making as much sense in a text file. But I found that large language models, especially nowadays, are actually pretty good at understanding what the intended format is, regardless of the actual representation of it. You're welcome.
Any other questions? You guys so much. One more time for Theo.